let's continue the topic and discuss one more question. Figure is already given. We need to find the area of the shaded region. You must be thinking that whole figure is shaded, right? But still there is a catch in it. What is that? Let's learn. Let's read the question first. Find the area of the shaded region in figure where a circular arc of radius 6 cm has been drawn with vertex O of a equilateral triangle ABC of side 12 cm as center. So let's understand what is given. O is the center of the circle. Yes, we come to know that it is given, and O is also the vertex of the equilateral triangle. Vertex means what? One point, you can say, where two lines are joining. So O is the vertex of an equilateral triangle and O is the center of the circle as well, right? One more thing, I think radius is also given, that is 6 cm. Yes, so radius is given 6 cm, good for us. And side of equilateral triangle, which is 12 cm. Okay, so we know there are 2-3 different kinds of triangles based on sides, based on angles. Here we are talking about equilateral. Equilateral means what? Equal, lateral means side, equal sides. So this triangle has all the sides are equal. We already learned in previous grades, right? We remember that. So this is equilateral triangle. So far we discussed about right angle triangle. So equilateral triangle. There is a formula to find the area of equilateral triangle. We learned this in grade 9 in the chapter of Heron's formula. I hope you remember. That is √3/4 a square. A is what? Side of the equilateral triangle, right? So we have formula to find the area of the triangle. Yes, we have the formula to find the area of this circle as well, right? So, and you can see that whole figure is even shaded. So what we need to do, very simple, find the area of circle, find the area of triangle, equilateral triangle, and add it. Are we done? No, we are not done there. There is some problem here. There is a very beautiful thing given in this question that we need to focus on. Let's start with the shapes first of all. What do we have and what we don't have? And if we just directly add those two areas, what mistakes are we going to commit if we do that? So first shape, that is circle, right? Easy to identify. We are talking about chapter of circle only, so obviously there will be circle. So circle, we have it, done. Now what about the next thing? Yes, triangle. Let me just draw a little bit over here. Triangle, equilateral triangle. Let's use the name as well, equilateral triangle. Now what's the problem if I connect them, right? See what will happen. Suppose I'm just overlaying this, okay, overlapping this triangle. So if you observe this area and this area over here, we are going to count 2 times. This is the problem is, right? This particular region, if I directly add the area of circle plus area of equilateral triangle, if I add, this area will be counted twice. This is the problem. We need to avoid it. So what can we do for that? Now when you see the circle, you must be getting an idea that it is sector. Yes, it is sector, all fine. But to find the area of the sector, we should be having angle theta. We should be having angle of theta, which is subtended at the center. Radius we have, I hope it is 6 cm. So we are fine that theta and r we need. But theta, we do not have it. So how to get the theta? Okay, let's pause there. Let's come to the topic of shapes. Here I have circle with me. Okay, done. Now what I am going to do, I am going to cut this sector out of the circle. So what will be the shape left of the circle? It will be something like this, right? So now you can see that this is the area that I need to take from this circle, and the same area, if I connect this equilateral triangle over here, right, I can see that this is the area of the shaded region. Understand, right? What have I done? Let me repeat one more time. Circle, I have it. I know that this area is repeated or counted twice, and I want to avoid that mistake. So what I will do, from this circle I will remove this area. How can I remove? Because it is sector. right? We know the formula for finding area of sector. So with that formula, I am going to count the area of sector and remove it, means subtraction, remember. So area of circle minus area of sector. Done? Good. Now simple, you just add these two and you get the shape you wanted. Done. Okay, so we know first step we need to find area of circle. So area of circle, right? Second step, area of sector. Done. Third step, here subtraction is coming first, see? Third step, subtraction. Fourth step, area of triangle. And fifth step, add. Simple, right? So let's recall the step one more time. Area of the circle first you need to find. Yes, we can do. Area of sector, then we need to subtract. Okay, area of triangle and add. So done. Now come to the circle. To find the area of circle we need radius. Do we have it? 6 centimeters. So let's start. Let's not wait. Let's start. First step, area of circle. So area of circle is equal to pi r square. So pi is 22 by 7, r is 6 here, 6 multiplied by 6 here, right? So we cannot do any cancellation here because 7 is in denominator and 6 there, all are even, so not possible. Let's multiply. So I think 22 into 66, 6 into 6, that's 36. So 22 into 36 divide by 7, and if you multiply, I think you are going to get around 792 divide by 7 centimeter square. Done? Simple. If you are not confirmed sure with the answer, you can multiply and go ahead. Done. So first step is done, area of the circle. Now come to the next step, area of the sector. Okay, let me mention. This is interesting point here. Let's see how much you remember of the previous grade. Area of the sector, right? Pizza, yes, area of the sector. Now formula here, theta over 360 degree into pi r square. Now here I told you that whenever circle and sector, when we find those two area, remember that we can substitute the same value over here, right? So theta over 360 degree multiplied by pi r square. What's the value? 792 over 7. So 792 over 7. Now the problem is with the theta. It's not mentioned what is the value that this particular equilateral triangle subtends at the angle. So how can we get the value of theta? It is not like that this sum we cannot do. Yes, there is a way to find theta, but I am asking you to think about it and let's see how can you get the value of theta. Okay, so let's come to the properties of equilateral triangle. There is a purpose to keep center of the circle and vertex of the equilateral triangle at the same point. The reason behind that, equilateral triangle has all angle what? 60 degree. Remember, it has all angles equal, which is 60 degree, right? So you can see over here that O is over here, A here and B, and that's a part of the circle, see? So what will be the angle for this sector? That is 60 degree. So let's write 60 degree over 360 degree multiply by 792 divide by 7. 0 0 cut, 6 1s and 6 792 divided by 6 you can do. How? See, because we have already 6 in the factor of this 792, right? Let's do it. 6 1s then 1 9, that is 3s, then 1 2, that is 2s. So 132 over 7 centimeter square. Done? Are we done with the area of the circle and area of the sector? So first step done, second done. Now third step, we need to subtract remaining area of the circle, right? So let's do the third step. Let's start with the third step. Third step let's do over here. Simple. Let's start with the Third step will be remaining area of circle. So let's write remaining area of circle. So what I need to do, remember, subtract bigger number minus smaller one, right? So obviously circle is bigger than the sector. So 792 denominator 7 minus 132 denominator 7. So let's see what do we get. Here 2 minus 2 will be 0, 9 minus 3 will be 6, 7 minus 1 will be 6. So 660 denominator 7 centimeter square. So we are done with the third step as well. Okay, there were many steps, but when we do, okay, there are many, no worries. So let's do the fourth step, area of the equilateral triangle. So that's a simple formula, root 3 by 4 a square. So let's do fourth step, area of equilateral triangle, that is root 3 by 4 a square. Now, what's the value of a? A is a side. It is already given in question, ready-made, nothing to worry about. So 12 root 3 by 4 into 12 into 12. So 4 1s are and 3s are. 12 3s are 36. So here 36 square root of 3. No denominator, no fractions, good. So centimeter square. Now, what's left now? Last step, which is finding the area of the shape, area of the shaded region. Done. So let's write final step, area of shaded region. So it is what? Am I going to add or subtract? See, it's written, we need to add. So triangle done, we need to add. Last step. So it's 660. Now be careful which area are you going to add. We are not going to add into circle. Remember, right? We need to add into this area, which is the remaining area after we remove the sector. So that is 660 denominator 7 minus what? 36 square root of 3, right? So here let's multiply with 7 and see what do we get. So 36 into 7, here 2, here 4, 7 3s are 21, 21 and 4 will give you 25. So 660 minus 252 square root of 3 denominator 7, that's the area of the shaded region. Done? Simple? Yes, there are many steps. There are 5 steps that we discussed with. Okay, but remember the area of equilateral triangle formula, which is root 3 by 4 a square. Here it is not possible to find the base. Base is there, yes, okay, but height is difficult to find, right? So this area will be helpful. This formula will be helpful. Let's recall the sum. Okay, when we see the figure, it looks that you have circle, you have equilateral triangle, add and we get it. No, but there is a catch. We will be counting the area of sector twice. So these are the steps. Area of circle, got it. Area of sector, yes, we can get, but remember property of equilateral triangle that it subtends 60 degree, right? So we get the area of sector. Then afterwards, from the circle, we move the sector. To remove, we need to subtract. So we have subtracted. Afterwards, get the area of equilateral triangle. Yes, we get it. And you add with this area. Remember, don't add that area. Otherwise, your all work which is done is in vain and wasted. So this is how we find the area when the particular part of those area is overlapping.